Let f is a function from n to n such that f of n is having two answers, n plus 1 by 2, n is odd, and n by 2 if n is even. Okay, check it is bijective. Check for bijective. Okay, now I told if by taking two distinct elements from this set, and answer is unique, means only one solution will come, then we can say this is 1 1. Now take some example. If you take n, suppose 1 2 3 4 5 to n minus 1, and n up to 2n you take even. Before that, before 2n it is odd. So what is fn? So when you take odd, 1 plus 1 by 2 1, 3 plus 1 by 2 2, 4 plus 5 plus 1 by 2 5 plus 1 by 2 3. So 2n minus 1 plus 1 by 2 n. Now if you take 2 1 4 2 and 2n n, means in this set this is n, in this set is also n. So all the elements, all the natural number from 1 to infinity, here 1 to infinity, every element of this set is not uniquely associated. Why? Because one is related to, suppose one is when I taken 1 and 2, two distinct element having same image, two distinct element having same image, that means this is by example. When I take an example, it is not 1 1. It is, if it is not 1 1, then it is what? Onto many one. Now for onto or into, every element of this set, suppose upper one is also natural and lower one is also natural. So each element of second set having at least one pre-image. That means range equal to codomain. So by seeing the example, we can say this function is not bijective. What it is? Many one onto. Now you check with the proper method. Let m n belonging to n, domain, this is your domain. Now f of m, so if you take f of m, you take, so m plus 1 by 2, m is odd, and now m by 2, m is even. This side and this side you see n plus 1 by 2, n is odd, n by 2, n is even. So here two things this side, two things this side, means we having four options, this side n, this side n, a b c d. So a related to c, a related to d, b related to c, b related to d. So we having four cases. Case 1, m plus 1 by 2 equal to n plus 1 by 2, where m and both are odd. So if you take both are odd, means what? M equal to n, which is correct. M equal to n. F of both the images are equal. If elements are equal, we taken the images, these are what? Answer means what? Images are, when I taken images, elements is equal. That means two distinct element having two distinct images. Next, up to here it is correct, it is 1 1. Now case 2, m plus 1 by 2 equal to n by 2, where m is even or m is odd and n is even. So m plus 1 equal to n, which is correct. Why? Odd plus 1 even, and this side is even. So this is also correct, which is true. Which is true. Now third case. Case 3, m by 2 by take this, I taken 2 by this, m by 2 equal to n plus 1 by 2, where m is even and n is odd. So this implies m equal to n plus 1. So m is even, odd plus 1, this is also even, which is true. So next, case 4, m by 2 equal to n by 2, where m and n both are even. So in this case, m equal to n. So here in all the 4 cases, we observe 2 answers is coming. So if there is more than one solution, then it is never 1 1. So in all the 4 cases, we observe from all cases f is into many one. This we can prove with the help of example also. So for proving many one, not 1 1, you can use example. What example? Suppose two distinct element you have to take in first set, and you have to show that images are same. So you don't take same, means one odd and then other you have to take as even. Suppose 1 comma 2 belongs to n, this is domain. So f of 1 if you find, then 1 plus 1 by 2 means 1. F of 2 if you find, n by 2, that is 1. 2 by 2, that is 1. So what you observe? F of 1 equal to f of 2, but 1 is not equal to 2. So two distinct element having same image. This is 1, this is 2, but both are related to 1. So this is many 1. This is not 1 1. Okay. So by taking example, with the help of examples, we can do, no issue. Now f is for on 2. For on 2, what we do? We have to take one arbitrary element in the second set. So that m belongs to n, this is what? Codomain. So here two cases, one is even and one is odd. Why? Because answer is, this is m. So sometime it is even or sometime it may be odd. So n plus 1 by 2 equal to m, and when n by 2 equal to also m. In both the cases The answer is m. So you see the value of n from here, one time when it is coming, n is odd and this is n is even. So n plus 1 by 2 equal to m, where n is odd. So n plus 1 equal to 2m. So n equal to 2m minus 1. For each m belongs to n codomain, there exists n belongs to natural number domain such that f of x equal to y. So f of n equal to, so what is the value of n? 2m minus 1. And what is n? N is odd. So if you take odd, the definition is, this is the definition, 2, if it is odd then n plus n minus 1 by 2 or plus 1 by 2, n plus 1 by 2. So what is n? N is 2m minus 1 plus 1 by 2. So this two thing we cancel. So it is what? M. So what you observe? F of n equal to m. So what it is? Range equal to codomain. So when I taken one case, here I taken the first case, case 1, on to case 1. This is range equal to codomain. So in case 1 it is on to. Now check the second case. Case 2, n by 2 equal to m, where n is even. So what is n? 2m. I retain the value of n in terms of m. So where n is even. So for each m belongs to n, m belongs to n means what? Domain, codomain. There exists n belongs to n domain such that, here we can write there exists a natural number n belongs to n such that f of n. So what is the value of n? 2m. 2m by 2. This is by definition. So it is what? M. So f of m equal to m. So what it is? Range equal to, you can say that is range f equal to domain, codomain. So in both the cases f is onto. So f is many one and onto. That is, f is not bijective. It is not bijective. Some more questions. Write fast. Question is, if let f is a function from R to R such that f of x equal to mod x, which is prove that f is neither 1 1 nor onto. Means it is neither 1 1 nor onto. Means what? Neither 1 1 nor onto. It is a case of many one. into. Indirectly we have to show many 1 into. So how we can? I told no case is always helpful for by taking example. So you have to take, this is also real and this is also real. The function is real number to real number. So what we do? We have to take two distinct element in their domain and we have to show, if I able to show two distinct element having two distinct images, then it is 1 1. But here I have to prove neither 1 1. That means neither 1 1, it is automatically many 1. So how it is? So you can take two distinct number, but numbers should be positive or negative. Why? Because if you take 1 and other you take 2, so see here, 1 or 2 belonging to n, this is the function, this is what r, this is what r, in minus infinity to plus infinity, minus infinity to plus infinity. But if you take from here 1, answer is mod 1, so 1. If you take 2, then it is 2. So two distinct image, two distinct element, two distinct image, sir, it is a 1 1. But you have to take, if you take minus 1, now you see, if you take minus 1, then answer is 1. So here we have to prove it is not 1 1, and I have to take that real number which not satisfy the case of 1 1. You don't take one positive, one negative, then two distinct images, then sir it is 1 1. So you have to check that number which not satisfied, that is a real number, but that is not satisfied with by the given condition. So now you can take 2 minus 2, 5 minus 5, whatever the number you want, you just take. So you take only minus 2 and 2 belongs to real number. This is domain, and f of minus 2. This is mod of minus 2 to f of 2. Mod of 2, this is 2. So since f of minus 2 equal to f of 2, both having same, but minus 2 and 2 are distinct. Two distinct elements, same image. So therefore f is not 1 1. If in the question it is neither 1 1, then you write not 1 1. But if it is many 1, then if you write f is many 1. Now check it onto or not. So you take any real number. Suppose if I take 1, it has two pre-image. If you take 2, then it has two pre-image, minus 2 and plus 2. So if it has two pre-image, then it is never. What I have to prove? We have to prove onto. Onto means every element of this set having at least one pre-image in this set. Okay, but I have to check it is satisfied by the onto condition or not. I told if it is not onto, then it is by default it is into. So you see, answer is always positive and positive, because real number to real number and mod function is there, so it always gives positive things. So for 0, if you take 0, then answer is 0. But if you take minus 1, then again it is plus 1. So here in this set, minus is also present. Now minus before 0, all the numbers having no pre-image. So you can select that number only. You take, since, or you can say let minus 2 belongs to R. This is what? Codomain. Codomain. Here minus 2 has no pre-image in domain R. So f is not onto. So not onto. Not 1 1, not onto. That means therefore f is neither 1 1 nor onto, we can say. And if it is many 1, then it is into. Neither 1 1 is the same case of many one into. And by graph also we can check it is many one or not. I told earlier, graph of modulus function, you just see V safe, the graph y dash x dash. How to check it is 1 1? I told one line draw but parallel to x-axis. If you draw one line parallel to x-axis, then the graph line intersecting in two distinct points, then what does it mean? It means if it is -1, answer is 1, and if it is +1, then answer is +1. So this is what? This is the case of 1 1. So if it is a case of it is not the case of 1 1, because two same distinct element, image same, so it is many one. So by graph also we can check it is many one or 1 1, that I already explained. Similarly, you can go through the Signum function. If you go through a square function, greatest integer function, so by the same concept you can utilize, and the Signum function is also neither 1 1 nor 1 2. Why? Because in case of Signum function, not Signum, it is Signum. Signum function. Signum function, the graph of Signum function is, so this is x-axis, y-axis. So you see so many point, here it is 0. Answer in place of 0, if you take 0, then it is 0. And if it is more than 0, then it is what? 1. This is the graph of x equal to 1. It is a line parallel to, height is always same, na? So it is, height is always same. This is 1, y is equal to 1, and here it is y equal to -1. So two distinct elements, same image, two distinct elements, same image. So this is never 1 1. And by graph, you see any line parallel to x-axis, so many answer will be there. So many input, output is same. So it is never 1 1. So Signum function is also not 1 1. And by seeing, if you go through the Signum function, range is coming. Range of Signum function is what? Range of Signum function -1, 0 and +1. And codomain is what? Because function is from R to R, so codomain is R. So range is not equal to codomain. Range of f is not equal to codomain. So it is never onto. So the Signum function is neither 1 1 nor onto. Actually, Signum function is defined in this way. F is a function from R to R such that f of x equal to mod x by x when x is not 0 and 0 when x equal to 0. Not 0 means here it has two conditions. Here two cases will be there, greater than 0 or less than 0. So greater than 0, then it is 1, and equal to 0, then it is 0, and if it is less than 0, then it is -1. So see, 3 answers will be there. Whatever input you can take, 3 output will come. So that is why range is never equal to codomain. So that is why it is neither 1 1 nor onto regarding Signum function. And one more function is there, that is greatest integer function. We can say it as greatest integer function. This is a ceiling function, floor function, step function, ceiling function, all are almost same. Here it is greatest integer function, and greatest integer function is also called step function, but both are, you can say it is a greatest integer function. One is smallest integer function. Greatest integer function is floor function, smallest integer function is ceiling function, and both are called, either you can say ceiling or floor, both are called step function. If you take first, if you say step function, then always suppose any if you 2 I written 2, that means it has +2. If it is 2, then where the decimal 2.0, just front of this. If there is the denominator, nothing is written, means 1 is there. So that means if I say step function, then it is what it is, floor function, and you can say it is greatest integer function. But when it is smallest integer function, then especially I have to say it is a smallest integer function or a ceiling function. But our question is what? Signum function is greatest integer function. You can say step function is also neither 1 1 nor on 2. Why? Because when you draw the graph becomes straight line like this. This type of line will come. It is a parallel to x-axis. That means two distinct elements having same image. So it is many one, not 1 1. And if you go through your answer, function is from R to R. So in second set, that numbers, suppose 1 by 2, root 3, that number never come, because answer is always coming in a form of integer. So that numbers are left out. That numbers having no pre-image in previous set. So we can say in greatest integer function or smallest integer function, that means step functions are not 1 1 on 2, means neither 1 1 nor on 2. It is what? Many 1 into. So okay, today I go through all the questions. Next day I will start composition of two functions. After that again we have to come through bisective function. Why? Because we have to find the invertible functions. So for that invertible functions we have to, so it is first of all it is 1 1 and on 2. So okay, thank you. Now go through all the lessons carefully, because these are very important and conceptual chapters. Okay, fine.